Welcome to our nocturnal laboratory of gentle discoveries. Here at Dreamtime Science, we transform complex concepts into lullabies for the curious mind. You know what's fascinating? I've been thinking about how tiny moments from long ago can get locked away in stone, like nature's own time capsules. There's something remarkable about fossils. Not just the way they form, but how they quietly tell us stories about creatures and worlds that existed millions of years before we were here. I can't wait to share with you the gentle secrets fossils hold and what they really reveal about our planet's past. A soft tap of the like button or a whispered subscription tells me these calming discoveries resonate with you. What aspect of science brings you the most wonder? Before we begin, create your sanctuary, nestle into your chosen spot, let your muscles soften, and allow your breath to find its natural rhythm. Let your mind settle into the hush of evening, where the world outside grows dim and quiet, and the only sound is the gentle rhythm of your own breath. In this tranquil space, let us step softly between the folds of time, for tonight we listen to the whispers of the past, silent voices preserved in stone, speaking to us across millions of years. Beneath our feet, hidden under layers of earth and memory, the planet holds a library unlike any other. Its shelves are not lined with paper or ink, but with bones, shells, impressions of leaves, and the subtle outlines of creatures long gone. These are fossils, relics of life from epochs before memory, before myth. Fossils, in their quiet way, are storytellers. They do not shout, nor do they sing, but if you learn to listen, their tales are more wondrous than any legend. They are the autobiography of Earth, each specimen a single, extraordinary page. To begin with fossils is to begin with wonder. Even the word itself, fossil, conjures up an aura of ancient mystery. It comes from the Latin fossilis, meaning dug up. Such a simple phrase for something so profound. For centuries, people found curious objects in the ground, shark teeth on mountaintops, shells embedded in cliffs, petrified wood in desert sands, and wondered what they could mean. Sometimes these discoveries became the seeds of stories, dragon's teeth, the bones of giants, the relics of gods. In the absence of scientific knowledge, imagination took root. It is easy to see why. Fossils are both familiar and strange, echoing present life but shaped by worlds we can barely imagine. Hold a trilobite in your hand, a small, segmented creature with a suit of armor, curled as if in sleep, and you cradle not only a fossil, but a memory of warm Cambrian seas 500 million years ago. Hold the curved tooth of a Tyrannosaurus, and you touch the shadow of a predator that thundered through forests when flowering plants were still newcomers to the scene. Our fascination with fossils is ancient. In China, dragon bones were ground into medicines for centuries, believed to contain potent powers. In Greece, the spiral shapes of ammonite fossils were called cornu ammonis, horns of the god Ammon, and in medieval Europe they became snake stones, supposedly remnants of serpents turned to stone by saints. Even the earliest paleontologists, before the science had a name, puzzled over these relics. Some thought they were tricks of the earth, stones grown in the shapes of animals by mysterious forces. Others saw them as evidence of past catastrophes, perhaps even the biblical flood. It was not until the Enlightenment, with the careful work of thinkers like Nicholas Steno and Mary Anning, that the true nature of fossils began to emerge. These were not mere curiosities, nor magical talismans, but the petrified remains of once-living organisms. Each fossil was evidence, hard, physical proof, that the world had once been very different, populated by creatures now vanished. The earth, it seemed, was far older and more changeable than anyone had dared to imagine. In the centuries since, fossils have become central to our understanding of life's history. They reveal not just what lived before, but how life has changed, adapted, and recovered from cataclysm. They tell us of times when the air was thick with ferns and dragonflies the size of hawks, when oceans surged across continents, and when strange reptilian titans, the dinosaurs, ruled the land. Fossils have overturned old ideas, forced us to revise our theories, and sparked endless debate. They are clues in a cosmic puzzle we are only beginning to solve. But fossils are more than scientific specimens. They have seeped into our dreams, into art and fiction, into the collective imagination. Consider the way fossils have become symbols of mystery, of power, of a lost world just out of reach. Nowhere is this more evident than in the stories we tell about dinosaurs. When Michael Crichton wrote Jurassic Park, he did not merely create a tale of adventure and terror. He tapped into a deep cultural vein. The idea that the past could be resurrected, that ancient giants could walk among us once more, is thrilling and a little frightening. The film adaptation, with its towering brachiosaurs and cunning velociraptors, brought these creatures to life in a way never before seen. Bones and stones, assembled with care, suddenly became flesh and blood, roaring, running, breathing. Audiences gasped, not only at the spectacle, but at the uncanny sensation of seeing time collapse, of the ancient world pressing up through the present. Jurassic Park is science fiction, but it draws its power from the truths unearthed by paleontology. The film's central conceit, that dinosaur DNA could be extracted from prehistoric mosquitoes trapped in amber, captures both the promise and the peril of fossil research. In reality, DNA degrades far too quickly to survive for millions of years, even in the best of conditions. The oldest authentic DNA ever recovered comes from mammoths and horses tens of thousands of years old, not millions. Still, the notion that fossils contain secrets locked away, waiting to be revealed, is not entirely fantastical. In amber, for example, we can sometimes find exquisite preservation. Not just bones, but feathers, skin, even the delicate anatomy of insects in flight. There is a profound intimacy in these finds, a sense of peering through a keyhole into the vanished rooms of history. Yet, as is often the case, fascination breeds misconceptions. One of the most persistent myths is that fossils form quickly, as if a fallen animal might simply sink into mud and within a few years emerge as a stony relic. In truth, fossilization is a process measured not in years or decades, but in epochs. Most living things do not become fossils. They are devoured, decomposed, scattered by wind and water. Only under rare and fortunate circumstances does the alchemy of preservation begin. Imagine a dinosaur brought low on the banks of a meandering river. Its body, heavy and warm, is quickly covered by silt as the river floods. The soft tissues are the first to go, devoured by scavengers or broken down by bacteria. Gradually, the bones become buried deeper, the weight of sediment pressing down, excluding air. Over thousands, then millions of years, minerals carried by groundwater seep into the bone, replacing organic material bit by bit, molecule by molecule. What was once living becomes, in effect, stone, a perfect replica, a cast, a ghost. Sometimes, instead of bones, we find only impressions, a ripple in the rock where a shell once lay, or the delicate outline of a fern leaf. These are trace fossils, shadows of ancient life rather than its remains. Even footprints, preserved in mud and later turned to stone, can become fossils. Such traces can be hauntingly direct. A line of dinosaur tracks across a prehistoric floodplain, frozen mid-step, as if the animal had just passed by and might return at any moment. Now and then, the process takes another turn. In rare cases, the original material is not replaced but encased. Think of insects or tiny lizards trapped in golden amber, their bodies preserved in 3 dimensions, their colors and structures almost intact. Or consider the mummified remains of mammoths preserved in permafrost, their flesh and hair still bearing the marks of ancient winds. These are not fossils in the strictest sense, but they tell similar stories, offering a different window into the past. Despite these marvels, it is important to remember how unlikely fossilization is. The very existence of fossils is a kind of miracle, a collision of chance, chemistry, and time. Each fossil is a survivor, not only of its own era, but of the eons that followed. It is the exception, not the rule. Human culture, however, is drawn to exceptions. Fossils, once thought to be magical curiosities, are now icons of knowledge, objects of desire and discovery. Museums display them with reverence, their ancient bones reassembled into towering skeletons. Children press their faces to glass, eyes wide with awe. Artists and writers inspired by their forms conjure new worlds, prehistoric jungles, epic battles, extinction and survival. Even in the digital age, with satellites orbiting and genomes sequenced, the allure of fossils endures. They remind us that the world was not always as it is now, that the familiar is only a recent invention. There is a further, subtler meaning to fossils too. They are not only testimonies to vanished creatures, but to the vastness of time itself. To hold a fossil is to grasp a fragment of deep time, a chronology so immense that ordinary reckoning falters. 1,000,000 years, 100 million, 1,000,000,000. These are not spans we can easily imagine. Yet fossils bridge that abyss, connecting us to beginnings and endings far beyond our senses. Still, there are those who wish for fossils to yield more than stories. The dream of extracting ancient DNA, of resurrecting lost species, lingers in the collective mind. It is a dream of reversal, of going back, of undoing extinction. But the truth, as paleontologists know, is more complicated. The past is not a tape that can be rewound at will. Fossils are not time machines. They are records, not portals. Their value lies not in the possibility of revival, but in the depth of memory they preserve. And yet, who can blame us for dreaming? The past is a foreign country, beautiful and tragic, and fossils are its postcards, faded, enigmatic, but real. Each one is an invitation to imagine, to wonder, to learn. In the darkness of night, as you drift towards sleep, let your thoughts wander through ancient landscapes. Picture the first forests, tangled and lush, where amphibians crawled onto land. Picture the warm, shallow seas teeming with trilobites and nautiloids. Picture the endless herds of hadrosaurs, the stalking shadows of predators, the hush of extinction, and the slow renewal of life. All these stories, and countless more, are written in stone, waiting for curious minds to read. There are still so many questions. How do fossils form, deep beneath layers of rock and soil? What can they tell us, if we learn to read their subtle script? What secrets lie hidden, waiting to be discovered? The journey into the past is only beginning, and the fossils, those quiet, enduring witnesses, are ready to guide us. And so, before the night deepens, let us pause here, listening still to the quiet voices of stone, and let the suspense of what lies beneath linger, unresolved, like the faintest echo of a lost world, just beyond reach. Beneath the surface of familiar landscapes, where roots seek hidden sustenance and stones lie undisturbed for centuries, the ground conceals a slow-motion theatre, one in which the drama of ancient life is played out not in the bright light of day, but in darkness, pressure, and the silent dance of molecules. Fossilization, that wondrous, elusive process by which the fleeting forms of living things become inscribed into the rock, is far more than a simple act of burial and preservation. It is a delicate web of chance, chemistry, and time, a symphony where countless variables must find harmony, and where even the tiniest shift in conditions can spell the difference between oblivion and eternity. To walk in imagination through the corridors of deep time is to encounter a paradox. Fossils, those stony echoes of vanished worlds, feel solid and immutable in our hands, yet their very existence is born of unlikeliness. Most living things vanish utterly, their bodies returning to the earth with scarcely a trace. Only rarely, and under circumstances both stringent and mysterious, are the remains of a creature spared the usual fate of decay and dissolution. The path from life to fossil is narrow, winding, and fraught with obstacles. Let us begin at the threshold, the moment of death. It is here that the first threads of fate are spun. A fallen animal or a shed leaf may seem, for a fleeting instant, to be poised for preservation, but the odds are against it. For in the open air, the ceaseless work of scavengers, bacteria, and fungi begins at once. Flesh is stripped, bones scattered, soft tissues vanish into the hungry ground. Rain and wind, roots and burrowing insects, all conspire to erase the evidence. If you have ever walked a forest path and seen the rapid vanishing of a fallen bird, you have glimpsed the first barrier to fossilization, the world's relentless appetite for recycling its own. Yet sometimes, improbably, circumstances intervene. Perhaps a sudden mudslide or a surge of river silt buries the body quickly, sealing it away from hungry mouths and the oxygen that powers decay. Or maybe a fine volcanic ash descends, blanketing a landscape in a pale shroud and capturing, in a heartbeat, the details of plants and animals alike. It is in these rare moments of rapid burial that the story of fossilization truly begins, a story written not in words, but in minerals, pressure, and time. The first act is one of exclusion. To become a fossil, the remains must be shielded from the processes that would otherwise dissolve them. Water, paradoxically, is both friend and foe. It can hasten decay, but it is also the agent through which minerals flow, ready to infiltrate and transform. In the anoxic depths of a stagnant pond, where water is still and oxygen scarce, decay slows to a crawl. In such places, even delicate tissues may be preserved, at least for a time. Elsewhere, quick burial in sand or silt may do the trick, especially if followed by compaction as layer upon layer accumulates above. And so the stage is set for the great transformation, a process known in its broadest sense as permineralization. Imagine the porous spaces within a bone, the intricate labyrinth of tiny channels that once carried blood and marrow. Over years, centuries, or even millennia, these voids become floodgates for mineral-rich water. The minerals, often silica, calcite, or iron compounds, precipitate out of solution, gradually filling every nook and cranny. Sometimes the original bone material remains, now fortified and encased. Other times, the minerals replace the organic matter entirely, atom by atom, leaving behind a perfect stone replica. This is how the bones of dinosaurs, the trunks of ancient trees, and the shells of ammonites come to rest in museums and collections, not as mere relics, but as intricate mosaics of ancient form and modern stone. But permineralization is only one path among many. The world beneath our feet is a patchwork of chemical environments, each with its own rules and exceptions. In some settings, mineral replacement goes further, obliterating the original material entirely. Shells of aragonite, an unstable form of calcium carbonate, may dissolve only to be replaced by more stable calcite, or even by the shimmering crystals of pyrite, fool's gold. In rare cases, silica-rich waters seep through the sediment, turning wood into petrified forests where the grain of the tree remains visible, but the substance is now a tapestry of quartz and agate. Elsewhere, fossils may be created not by addition, but by subtraction. Picture the mold and cast, a kind of negative and positive impression etched into stone. Here, the organism's hard parts dissolve away, leaving an empty cavity in the sediment. Later, that void may become filled with new minerals, creating a cast, a replica of the vanished form, sculpted by absence as much as by presence. Such fossil casts and moulds are common in ancient limestones and shales, where the original shells have long since vanished, but their memory persists in stone. Some of the most exquisite fossils are the result of carbonization, a process that occurs under conditions of great pressure and heat. As layers of sediment accumulate and compress, the soft tissues of plants or animals are driven to release their volatile components, leaving behind a thin film of carbon, a shadow, dark and delicate, pressed between sheets of rock. The graceful fronds of ferns, the outlines of fish, even the soft bodies of jellyfish have been immortalized in this way, their forms rendered as ghostly silhouettes in ancient shales. These various routes to fossilization are shaped by an intricate interplay of factors, each with its own set of demands. The chemistry of the surrounding sediment, the presence or absence of oxygen, the rate at which burial occurs, the mineral content of groundwater, all conspire to determine the fate of a would-be fossil. Even the pH of the environment plays a role. Acidic soils tend to dissolve bone and shell, favoring the preservation of plant material in the form of lignite or coal, while alkaline settings may preserve shell and bone but destroy organic tissues. Yet there are still more extraordinary forms of preservation, each offering glimpses into the ancient world that are as tantalizing as they are rare. In the sticky embrace of amber, for example, the resin of long-dead trees has trapped insects, spiders, and even tiny vertebrates, freezing them with astonishing fidelity. Here, the preservation is so complete that the intricate hairs on a bee's leg, or the iridescent colors of a prehistoric fly's eye, may be seen under magnification. The chemistry of the resin excludes water and oxygen, halting decay in its tracks, and over millions of years the resin hardens to amber, a golden window into the vanished forests of the past. Elsewhere, in the icy grip of permafrost or the arid vaults of salt mines, entire bodies of mammoths, bison, and other Pleistocene giants have been preserved, flesh and hair intact. The cold or salt acts as a preservative, desiccating tissues and halting the advance of decay. These are not fossils in the strict geological sense, for their tissues have not turned to stone, yet they offer a rare and poignant connection to the living past, a reminder that the boundary between the ancient and the modern is sometimes wafer thin. Perhaps the most remarkable mode of preservation is that which captures not the hard parts, but the soft, the eyes, muscles, and even the contents of a stomach. Such miracles occur only under the most extraordinary circumstances. The Burgess Shale of Canada, the Chengjiang deposits of China, and a handful of other sites around the world bear witness to this rare alchemy. Here the chemistry of the sediment and the absence of oxygen have combined to preserve even the most delicate tissues, offering a glimpse into the Cambrian explosion and the dawn of complex life. These Lagerstätten, as they are called, are treasure troves for paleontologists, illuminating forms and relationships that would otherwise be lost to time. Yet for all our understanding of these processes, the jigsaw is far from complete. The fossil record is a patchy, selective chronicle, shaped by both the accidents of preservation and the biases of discovery. Soft-bodied creatures, for instance, are vastly underrepresented, their remains only rarely surviving the rigors of deep time. The environments most conducive to fossilization, quiet lagoons, river deltas, volcanic ash beds, are themselves unevenly distributed across the globe and through history. Whole forests, mountains and oceans have risen and vanished, taking with them the evidence of entire ecosystems. Even among the fossils we do find, mysteries abound. Consider the question of color. For centuries, it was assumed that the vibrant hues of ancient feathers, scales, and shells were lost forever. Yet in recent years, the discovery of microscopic structures called melanosomes, tiny pigment-bearing organelles, has allowed scientists to reconstruct, in some measure, the colors of dinosaurs and birds whose only legacy was stone. The patterns and shades of ancient plumage, once thought irretrievable, are now being teased from the rocks, pixel by pixel. Still, there are puzzles that defy even our most sophisticated tools. The preservation of DNA, for instance, remains a frontier fraught with intrigue and debate. In rare instances, fragments of genetic material have been recovered from amber, permafrost, or ancient bones, but the passage of time is relentless. Radiation, chemical reactions, and simple entropy conspire to break the delicate strands, fragment by fragment, until only the faintest whisper remains. The dream of resurrecting extinct species from their ancient blueprints persists in popular imagination, but the reality is a mosaic of hope and frustration. There is, too, the enduring enigma of gaps, intervals in the fossil record where whole lineages seem to vanish only to reappear much later. Are these true extinctions, or the result of preservation bias and the vagaries of discovery? The debate continues, fueled by each new find and every missing piece. The fossil record is a palimpsest, overwritten by the forces of geology and time, and it is as notable for its silences as for its revelations. Even the very definition of a fossil can be slippery. At what point does a bone, a shell, or a leaf cease to be a mere remnant and become a fossil? Is it a matter of age, of mineral content, of context? The boundaries are blurred, and paleontologists must tread carefully, weighing evidence and context with every new discovery. There are fossils that defy easy classification, the so-called trace fossils, the tracks, burrows, and coprolites, fossilized feces, that record not the bodies of ancient creatures, but the traces of their passing. These, too, are part of the ancient jigsaw, offering hints about behavior, ecology, and the invisible webs of interaction that shape the living world. The complexities of fossilization, then, are both daunting and exhilarating. Each fossil, however humble, is the product of 1,000 contingencies, a survivor of disasters, of dissolution, of the grinding jaws of the earth itself. To hold a fossil is to touch a paradox, a thing both impossibly ancient and improbably preserved, a fragment of a world that no longer exists and yet is present here, in your hand. As we contemplate these stony relics, we are left with questions that reach beyond science and into the realm of philosophy. What stories are lost, forever buried in the unrecorded epochs? What wonders might still lie hidden, waiting for the slow hand of erosion or the patient brush of a paleontologist to bring them to light? The Earth's crust is a vast archive, written in a code both subtle and profound, and the process of deciphering it is far from complete. So the next time you press your palm to the rough surface of a fossil, or trace the spiral of an ammonite with a fingertip, remember the layers of chance and chemistry that conspired to bring it to you. Consider the myriad paths that life and death, decay and preservation have woven together beneath the earth, and let your thoughts linger on the puzzles that remain unsolved, the invisible stories, the missing layers, the riddles locked in stone, knowing that the journey into the past is always unfinished, always beckoning us deeper into the unknown. For beneath the surface, beyond the reach of sunlight, new chapters are still being written, and the next revelation may be just a stone's throw away, waiting for the patient seeker to uncover its ancient silent tale. In the quiet dawn, when the world is veiled in a gentle mist, and the first shafts of sunlight coax colour from the rock and soil, there are those who crouch close to the earth, fingers dusted with ancient silt, eyes scanning for the faintest pattern that does not quite belong. These are the paleontologists, readers of the stone script, interpreters of the earth's deep memory. With each patient brush and careful stroke, they coax stories from the bones and shadows of creatures that lived and died long before the first human gaze swept these valleys and cliffs. The discipline of paleontology is as layered and intricate as the sedimentary rocks that cradle its treasures. It is a science born of curiosity, matured by rigor, and nourished by a kind of reverence for the ancient world. Its history is peopled by characters whose lives are as compelling as the fossils they uncovered, and its progress is marked by both painstaking labour and flashes of inspired insight. Let us begin, then, on the windswept cliffs of Lyme Regis, along England's Jurassic coast, in the early years of the 19th century. Here, the sea gnaws at the blue Liar's Cliffs, exposing fresh faces of rock with every storm. A young woman, Mary Anning, scours the beach after each landslide, her keen eyes searching for the glint of a vertebra, the curl of an ammonite, or the outline of a skull. She is poor, self-taught, and at first ignored by the scientific establishment. Yet her hands are sure, her instincts uncannily precise, and her discoveries will fundamentally alter humanity's understanding of the prehistoric past. Mary's most famous find is the first complete ichthyosaur skeleton, unearthed when she is just 12 years old, and later the first recognized plesiosaur. To the people of Lyme Regis, these are curiosities, sea dragons to be sold to tourists. But to geologists and naturalists, they are revelations, fossils of creatures unknown in living memory, their strange forms speaking of vanished worlds. Anning's careful work, her meticulous field notes, her reconstructions of the skeletons, her knack for distinguishing bone from stone, lays the groundwork for the new science of paleontology. Though she does not receive the recognition she deserves in her lifetime, today she is rightly celebrated as a pioneer, her legacy enduring in the halls of museums and the names of ancient species. The tools of Mary Anning were simple: a hammer, a small chisel, a sturdy basket for carrying finds, and the most important of all, patience. But as the discipline grew, so too did its arsenal of techniques and its circle of practitioners. The mid-19th century saw the rise of the bone wars in the wilds of the American West, an era of fierce rivalry, adventure, and sometimes questionable ethics. Two scientists, Othniel Charles Marsh and Edward Drinker Cope, competed to outdo each other in discovering and naming new dinosaurs. Their teams braved rattlesnakes and bandits, endured the harshness of the Badlands and the baking sun of Wyoming, all in pursuit of bones that would rewrite the history of life on Earth. The race was not always noble. Fossils were sometimes destroyed to prevent rivals from claiming them. Names were hastily assigned, errors made, egos bruised. Yet amid the tumult, genuine advances were made. Stegosaurus, Triceratops, Diplodocus, names that have become part of the world's collective imagination, were introduced to science. The fossil sites of the West became laboratories under the open sky, and the bones unearthed there were sent in crates and barrels to distant museums, where they would be studied, debated, and slowly pieced together like immense three-dimensional puzzles. As paleontology matured, the focus shifted from mere collection to analysis, from spectacle to understanding. Fossils are not just objects. They are messages encoded in mineral and time, awaiting interpretation. To read them, paleontologists developed new methods, drawing from geology, chemistry, physics, and biology. One of the most elegant of these techniques is stratigraphy, the study of rock layers, or strata. Each layer of sediment tells a story of its own, laid down in sequence by rivers, lakes, or seas, sometimes interrupted by volcanic ash, or marked by the sudden influx of material from a catastrophic flood. Fossils found within these strata are time-stamped by the rocks that cradle them. By carefully mapping the succession of layers, paleontologists can reconstruct the order of events in deep time, placing the rise and fall of species within a broader tapestry of environmental change. Yet the rocks do not always yield their secrets easily. For generations, the age of the Earth was a matter of speculation, debated in the salons of Europe and the classrooms of universities. It was only with the advent of radiometric dating in the 20th century that the vastness of geological time could be measured with precision. atoms of uranium decaying into lead, potassium into argon, these natural clocks tick away within the crystals of minerals, allowing scientists to calculate the ages of rocks and, by extension, the fossils they contain. The Earth is not thousands of years old, but billions. Life's history is not a brief prelude to the human story, but an epic drama played out over eons. As tools advanced, so did the questions paleontologists could ask. The microscope revealed microfossils, tiny shells and pollen grains, the detritus of ancient seas and forests. These minuscule remains are crucial for understanding the climates and environments of the past. They tell of ice ages and greenhouse worlds, of vanished lakes and expanding deserts. Chemical analysis of fossilized bones and teeth reveals the diets of extinct animals, the migration routes of herds, even the stresses of drought and disease. The 20th century brought new ways to peer inside stone and bone. X-rays and computed tomography, CT scanning, allowed scientists to see the internal structure of fossils without damaging them. Paleontologists can now study the tooth roots of a dinosaur, the delicate bones inside a fossilized bird's wing, or the unhatched embryo curled within an ancient egg. Digital technology enables virtual reconstructions. Skeletons are scanned, modeled, and animated, tested against the laws of physics to infer how a creature moved, how fast it could run, how it might have hunted or evaded predators. Some of the most astonishing revelations have come from the careful study of exceptional fossil sites, places where the conditions for preservation were just right, where entire ecosystems were entombed and fossilized with exquisite detail. The Burgess Shale, high in the Rocky Mountains of Canada, is one such place. Here, soft-bodied creatures from the Cambrian explosion are preserved in black shale, their forms flattened but their anatomy astonishingly complete. For the first time, paleontologists could see not only the hard shells and bones that usually survive, but the delicate gills, eyes, and appendages of ancient animals, some so strange that they seem almost alien. Another wonder lies in the fossil beds of Liaoning, northeastern China. Here, in lake sediments dating to the early Cretaceous, dinosaurs are preserved with their feathers intact, a soft halo of down or a mantle of quills. These fossils have revolutionized our understanding of the origins of birds, showing that flight evolved in stages, that dinosaurs were often warm-blooded and colorful, and that the boundary between dinosaur and bird is blurred rather than sharp. Yet for all the advances in technology, there remains something elemental about paleontology, something that links the laboratory to the field, the high-tech scanner to the solitary figure on a lonely beach. The discipline still depends on the human senses, the eye trained to recognize the subtle curve of a fossil in matrix, the hand steady enough to separate bone from stone, the nose attuned to the scent of earth freshly split. Fieldwork is often uncomfortable, even dangerous. It demands endurance, ingenuity, and a certain humility before the immensity of time. Consider the story of Roy Chapman Andrews, an American explorer whose expeditions to the Gobi Desert in the 1920s became the stuff of legend. Andrews and his team traveled by camel and motorcar across the shifting sands, braving bandits and sandstorms. In Mongolia's flaming cliffs, they made a discovery that electrified the world. The first dinosaur eggs ever found, nestled in the ochre sands. Until then, the reproduction of dinosaurs was a matter of speculation. Now, for the first time, science could glimpse the earliest moments of dinosaur life. The eggs, the nests, even the embryos within testified to a world in which dinosaurs cared for their young, built nests, and perhaps even brooded like birds. Not all paleontology takes place in distant deserts or remote cliffs. Sometimes the most remarkable finds are made in quarries, road cuts, or even in the basements of museums, where forgotten fossils await rediscovery. In the chalk of Kansas, fossil hunters once unearthed the remains of a gigantic marine reptile, its stomach containing the bones of its last meal, a snapshot of predation in a vanished sea. In the tar pits of La Brea, in the heart of Los Angeles, thousands of bones have been pulled from sticky asphalt, saber-toothed cats, dire wolves, mammoths, and even the footprints of ancient birds. The methods of extraction and preparation have grown ever more refined. When a promising fossil is located, the surrounding rock is painstakingly chipped away with dental tools, air scribes, or even delicate needles under a microscope. In the field, larger specimens are often wrapped in layers of wet paper and burlap soaked in plaster, creating a protective jacket for transport. In the laboratory, chemical baths may be used to dissolve the matrix, or lasers to reveal details invisible to the naked eye. Each step is a balancing act, to expose as much as possible without destroying the delicate original. And then comes the interpretation. Fossils are not always what they seem. Bones can be broken, scattered, compressed, or altered by the slow chemistry of the earth. The act of reconstruction is as much art as science, requiring intuition and imagination, as well as a grounding in anatomy and biomechanics. Sometimes a single tooth or fragment is all that remains. Sometimes entire skeletons lie in articulation, as if the animal simply lay down and closed its eyes forever. Paleontologists compare the unknown with the known, drawing on the anatomy of living creatures, the arch of a bird's wing, the hinge of a crocodile's jaw, to breathe life into stone. Through all these efforts, paleontology has become a bridge between the lost worlds of the past and the vibrant tapestry of life today. It is a science of patience and persistence, of sudden insight and long labor, of solitude and collaboration. The tools have changed, the questions have grown more nuanced, but the heart of the discipline remains, the quest to read the stories written in stone, to hear the voices of the ancient earth. And so, as night falls and the stars wheel overhead, the fossil hunter's lamp still flickers in distant places, casting its glow on bones half buried in silt or shale. The work is never truly finished. There are always more stones to turn, more questions to ask, more secrets waiting in the deep, dark folds of time. Yet even as science probes ever deeper, the mystery only deepens, drawing us onward, toward the tangled branches of the tree of life, and the ever-unfolding story of our own place within that ancient, restless world. Somewhere, perhaps, in a quiet laboratory, or on a windswept plain, a new discovery is taking shape. A fossil being revealed, a puzzle piece falling into place, a chapter in the great saga of life on Earth, opening just a little wider. What remains to be uncovered, and what new tools might be forged for the reading of stone, only the future can tell. But even now, in the gentle hush before sleep, you can almost hear the soft, inexorable ticking of geological time and the faint, persistent whisper of the fossils beneath your feet. Beneath the quiet hush of ancient stone, where eons have been compressed into cryptic layers, fossils lie like punctuation marks in the epic poem of life. Each fossil, whether a spiraled ammonite or the delicate impression of a fern frond, embodies both a singular story and the collective mystery of vanished worlds. To contemplate fossils is to sit at the shoreline of deep time, listening to the echoes of extinction and emergence, and to wonder, with a mixture of humility and awe, about our own brief flicker in this immense unfolding. There is a strange intimacy in holding a fossil, in knowing that within your palm rests the memory of a vanished organism, something that once moved or grew or hunted or flowered in a world unrecognizably different from our own. The ammonites, with their coiled shells, swam the warm, shallow seas of the Jurassic, unfurling their tentacles to snatch prey, while above the air was filled with the cries of pterosaurs and the shadows of distant thunder lizards. Now the ammonite's stony imprint is cool and silent, its living moment reduced to a trace in calcite or pyrite. The fossil is at once a presence and an absence, a shape that testifies to what was and to what will never be again. To reflect on fossils is to confront extinction, not as a singular event, but as a recurrent theme, a rhythm in the grand music of life. The rocks beneath our feet are a palimpsest of lost epochs, each marked by the sudden disappearance of multitudes. The trilobites, armoured and many-eyed, once carpeted the Cambrian seas in such profusion that their remains are found by the bucketful in some ancient shales. For hundreds of millions of years they endured, adapting to changing seas and shifting continents, and then, with the closing of the Permian, nearly all were gone, victims perhaps of sudden climate chaos, oceanic anoxia, or the convulsions of the earth itself. Extinction, we realize, is not merely a tragedy, but a necessity, an engine of renewal, of creative destruction. In the wake of each mass extinction, life rebounds with astonishing vigor, filling the emptied ecological niches with new forms, new strategies, as if evolution itself is engaged in perpetual improvisation. The fossil record is strewn with these moments of abrupt ending and exuberant beginning. The dinosaurs' reign, so long and so varied, ended in the blink of a geological eye, but from their ashes rose the birds, every robin and raven a living testament to survival and transformation. The mammals, once small and furtive, inherited a world suddenly emptied of giants, and in time one lineage would develop the capacity to contemplate its own origins. Fossils speak to us not only of endings, but of persistence, the improbable thread of continuity that links the living to the long dead. The horseshoe crab, whose armour has changed little since the Ordovician, is an emissary from a world older than trees. The ginkgo tree, with its fan-shaped leaves, was already ancient when the first flowering plants appeared. In their presence, we sense the resilience of life, the capacity to endure through cataclysm and calm, to adapt and persist, even as the background conditions of existence shift like sand dunes in a restless wind. Yet there is also an undeniable fragility. The vast majority of all species that have ever lived are now extinct. The fossil record is a monument to this relentless winnowing. For every form that persists, countless others have vanished, their lineages reduced to silence. Some, like the Burgess Shale creatures, seem to us so strange, so unlike any living thing, that they remind us how contingent evolution is, how easily another roll of the cosmic dice might have led to a planet full of creatures utterly unlike those we know. And for every fossil that has been preserved, millions more have crumbled to dust, their stories lost forever. This realization that extinction is both the rule and the crucible of innovation invites us to ponder our own place. The human species, so young in the context of deep time, has become a geological force, a maker of fossils, a sculptor of extinction. Our bones, our cities, our artifacts will one day settle into the sedimentary record, joining the ammonites and trilobites as evidence of a vanished epoch. What will be left of us, and what will it mean to those who come after, if any are left to wonder? Some philosophers have likened the fossil record to a kind of collective memory, a story written in the language of stone. Yet it is a memory with gaps and silences, a narrative full of ellipses and erasures. The act of paleontology, the careful extraction and interpretation of fossils, is an act of translation, of reconstructing worlds from fragments. It is in part an exercise in humility, a recognition that our understanding will always be partial, our reconstructions provisional. The rocks do not give up their secrets easily. Even the best preserved fossils offer only hints, the curve of a jaw, the angle of a limb, the faint outline of a feather or a leaf. Much must be inferred, much remains forever beyond our grasp, and yet, in these fragments, there is wonder, The fossil record reveals that the world is not fixed but in flux, that the forms of life are endlessly mutable, that what seems permanent is in fact ephemeral on the scales of geological time. This perspective can be at once unsettling and liberating. It challenges our assumptions of stability, our sense of human centrality, our yearning for permanence. To see ourselves as part of this vast, branching tree, a single recent twig on an ancient storm-battered trunk, is to recognize both our kinship with all life and our impermanence within it. Fossils also confront us with the mystery of time itself. The intervals they measure are vast beyond ordinary reckoning, millions, even billions of years. The mind strains to hold such spans, to imagine the slow accumulation of sediment, the rise and fall of seas, the drift of continents. A single fossil, perhaps no bigger than a thumb, may encapsulate a moment from a world so old that the stars above it were arranged differently, the moon closer, the air richer in some vanished gas. When we hold such a fossil, we are touching not only another life, but another world, a world that is both utterly lost and through us momentarily resurrected. There is a temptation, perhaps, to draw lessons from extinction, to see in the fossil record a warning or a guide or a source of consolation, and indeed there are lessons to be found. The record of life's history tells us that change is inevitable, that no species, however mighty, endures forever. It teaches us about the interconnectedness of all living things, about the delicate balance of ecosystems, about the unforeseen consequences of environmental disruption. The great extinctions of the past were often triggered by forces beyond the control of any single organism. Volcanic eruptions, asteroid impacts, sudden climate swings. Today, however, it is human activity that drives many of the changes. Habitat loss, pollution, the warming of the planet, the acidification of the seas. The fossil record is becoming, in part, a record of our own making, but there is also, in the contemplation of fossils, a kind of solace. We are reminded that life is tenacious, that it rebounds and diversifies in the aftermath of catastrophe, that the end of one world is often the beginning of another. The knowledge that we are part of this ongoing story, that our atoms have been part of countless other lives, that our world is shaped by the detritus of the dead, can instill a sense of continuity, of belonging to something far larger than ourselves. At the same time, fossils evoke a sense of mystery that cannot be dispelled. There are creatures in the record whose affinities are still debated, whose lifestyles are matters of speculation. The Ediacaran biota, for example, leave us puzzled. Were they animals, fungi, or something else entirely? Their soft bodies left only the faintest impressions, like sighs in ancient mud. The truth of their existence recedes as we approach it, like a mirage on a distant shore. Even the familiar dinosaurs harbor mysteries, the colors of their scales or feathers, the sounds they made, their social lives, their dreams, if such a concept can be applied to a creature of the Mesozoic. This sense of mystery is not a failing, but a gift. It reminds us that the world is deeper and stranger than we can know, that knowledge is always incomplete, and that wonder is an attitude worth cultivating. The fossil record, with its mixture of revelation and enigma, invites us to approach the world with curiosity and reverence, to ask questions even when answers are elusive, to find beauty in what is unknown as well as in what is revealed. The philosophical implications of fossils ripple outward, touching on questions of identity, mortality, and meaning. If all things pass, if extinction is the fate of species as surely as death is for individuals, what then is the value of life? Some might find in this a kind of nihilism, a sense of futility. But there is another, more hopeful reading. The brevity of any one life or any one species does not diminish its significance. Rather, it heightens it. To exist at all, to be part of this fleeting parade of forms, is itself extraordinary. Fossils remind us that every moment is unique and unrepeatable, that every living thing is both a consequence of the past and a contributor to the future. There is a further paradox here, for fossils are both the most tangible and the most elusive evidence of life's history. They are the bones and shells and leaves that have survived the ravages of time, yet they are also reminders of all that has been lost. The fossil record is at once a triumph of preservation and a catalogue of absence. For every dinosaur skeleton mounted in a museum, there are countless creatures who left no trace at all, and yet, even in this incompleteness, there is a kind of wholeness, an understanding that the world is made not only of what endures, but also of what passes away. As we gaze upon the fossilized remains of ancient life, we are asked to imagine worlds that existed long before us, to see ourselves not as the culmination of creation, but as participants in an ongoing drama whose ending we cannot foresee. The dinosaurs, the trilobites, the sea lilies, the armored fish, all had their moment in the sun, all flourished and faded, all are now silent, except for the stories their remains allow us to tell. In the quiet hours, when the world itself seems to slow, one might find solace in these echoes of extinction. The lessons of the fossil record are not simple, nor are they always comforting, but they are profound. They tell us that change is both inevitable and creative, that life is fragile and resilient, that the present is built upon the unimaginable depths of the past. As we look forward, uncertain of what is to come, the fossils whisper that we are part of a much larger tapestry, one woven of loss and renewal, of endings and beginnings, of silence and song. And so, as the night deepens and the stars wheel overhead, the stones beneath us continue to hold their secrets, patient and enduring. Somewhere, in the darkness, the next fossil is being formed, the memory of today's life pressed gently into tomorrow's rock. The world is always becoming, always vanishing, always beginning anew. As our journey through the ancient whispers of fossils gently drifts to a close, like a comet tail fading into the hush of space, we find ourselves wrapped in the quiet stories etched beneath time's endless sky. May these silent echoes cradle your dreams tonight, inviting peaceful wonder as you rest. Until we meet again among the stars, come back for more Dreamtime tales that illuminate the mysteries of our cosmic home.